All right, so we're going to just continue. This is going to be part 2 of section 3.3. And that's a little bit harder, but I'm going to use my calculator to get most of what I need to get. So I have an initial function that I want to graph. In this case, it's f of x equals x, absolute value of x plus 1. For this graph right here, I'm going to not use the table -2, -1, 0, 1, 2. To figure out the number for the middle of my x column, if I'm asked to graph an absolute value function, I'm going to put a number in the middle of my x column, if it's not just an absolute value of x, that comes from solving the radicand equal to 0, the argument of the absolute value equal to 0. So I'm going to set this f of x plus, I'm going to set the x plus 1 equal to 0. And the table that I'm going to use to graph f of x equals absolute value of x plus 1 is going to have a -1 in the middle of my x column. So I'm going to graph x and f of x. In the middle of my x column, I'm going to put the number -1. And then I'm going to get smaller and do -2 and -3, and then bigger and go 1, 0, and 1. So when you're graphing a more complex absolute value function, if there's an addition or subtraction under the absolute value, you take the argument and set it equal to 0. That will anchor your x column, and now I'm going to get my y's using my calculator, and I'm going to sketch my graph. So I'm going to do y equals clear math number absolute value of x plus 1. Second table, next to -3, I get 2. Next to -2, I get 1. Next to -1, I get 0. Next to 0, I get 1. And next to 1, I get 2. So I'm going to plot those points on my graph. So I'm going to plot the point -3, +2, -2, +1, -1, 0, 0, 1, 1, 2. And absolute value graphs almost always come out to be V's. I can't think of a time where they wouldn't come out to be a V. And so I construct my tables so the point of the V is right in the middle of my table, which is helpful. If you don't pick your table cleverly, then you're not going to see maybe the whole V. All right, so that's part A. Your problem is number 7, and when you go to do part A, to figure out the number that goes in the middle of my x column, you're going to go x plus 3 equal to 0. You're going to go -3, -3, and you'll get x equal to -3. Your table is going to have -3 in the middle of your x column, and you'll go smaller, -4, -5, and bigger, -2, -1. So if you wanted to get started with your 7, you can start with that table. The next thing is my part B, and in each of the first 6 problems, the number that was added or subtracted was inside the parentheses in the function notation. Here, it's not inside the parentheses. It's physically after the f of x symbol. And to find f of x minus 4, the f of x symbol is going to be replaced with the absolute value of x plus 1, and the -4 is just going to be tacked on afterwards. It's not going to go inside the parentheses or under the absolute values because it's after the function. So the answer to part B, the function that I'm looking for in number 8b, is f of x minus 4 equals the absolute value of x plus 1 minus 4. In some sense, this next group of problems in section 3.5, it's going to be easier, and in some sense it's going to be harder. For each of the first 6 problems, I was able to produce a column of x's that made the y's exactly the same. In these next bank of problems, I don't think it's possible to create a column of x's that make the y's exactly the same. If a number isn't inside a parentheses of the function notation, you're going to use the same x column. So when I go to graph part C of this, I'm going to, let me get a fresher marker here. I'm going to use the same x column. So when I go to do part C, I'm going to have a column that says x and a column that says f of x minus 4. And I'm going to use exactly the same x's, -3, -2, -1, 0, and 1. I'm going to get the y's on my calculator by entering the function absolute value of x plus 1 minus 4. So I'm going to go y equals. I already have the absolute value of x plus 1. I don't need to type it again. I'm just going to arrow over and type a minus 4 afterwards. And I'm going to check out my y's and check out my graph. So now I'm going to go second table. I want to go next to -3, and next to -3 the y is -2. Next to -2 the y is -3. Next to -1 the y is -4. Next to 0 the y is -3. And next to 1 the y is -2. And I'm going to plot those 5 points. So I've made my table of values stealing exactly the same x's, and I'm going to plot the point -3, -2, -2, -3, -1, -4, 0, -3, and 1, -2. I just plotted those 5 points, and I'm going to make my lovely V. Absolute values are really nice graphs to see the shifting, more so than parabolas. So there's the graph of f of x minus 4 with the 4 after, not inside the parentheses. Part D asks me to describe how the graphs are related. This graph and that graph are, the purple graph is shifted down 1, 2, 3, 4 units. So to get from the black graph to the purple graph, you just shift it down 4 units. So we're going to say this shifts down 4 units as opposed to left or right. Now I'm going to move on and do part E, F, and G. Part E wants me to find f of x plus 3. Well, if f of x is the absolute value of x plus 1, then f of x plus 3 with the 3 not inside the parentheses, that's just going to be the absolute value of x plus 1 plus 3. So my answer to part E, f of x plus 3, is going to equal the absolute value of x plus 1 plus 3. Next part, make a table of values and sketch a graph. Again, when a number is added or subtracted outside the function, I use the same x column. So for part F, the graph, I'm going to have x and f of x plus 3. I'm going to use -3, -2, -1, 0, and 1 for my x values. And now I'm going to graph that function, absolute value of x plus 1 plus 3. Break out my calculator, y equals, absolute value of x plus 1 is already there. I'll type it again anyways. I'll go math, number for absolute value, x plus 1, close out my parentheses, plus 3, then hit second table, and I'm looking for -3. Next to -3 is positive 5, so I'm going to write -3, 5. Next to -2, I see 4. Next to -1, I see 3. Next to 0, I see 4. Next to 1, I see 5. So I'm going to plot those 5 points on my graph that I've already done 2 graphs on. Do them in red just to make them stand out. So now my graph is going to have the point -3, 5 first. So -3, positive 5. And then the next one is -2, 4. So -2, 4, and then negative 1, 3, and then 0, 4, and 1, 5. 0, 4, and 1, 5. Get another v, because absolute values come out to be v's. And all these v's, if you just slid them back and forth, would fit directly into each other, unless you kind of don't draw the graph so nicely. All these lines should be parallel, although mine didn't look quite parallel there. And if I compare the black graph to the red graph, the red graph is 3 units up from the black graph. So if I want to describe how to get the red graph starting at the black graph, I just take the black graph and shift it up 3 units, I'll get the red. And that's because of this plus 3 that's after the function notation. So for part G, it's going to shift up 3 units as opposed to left or right 3 units. That's the whole crux of this video. The next 6 problems are going to move a graph up and down. And in the last video, we added or subtracted a number using function notation inside of parentheses. A plus inside of parentheses, I could make all the y's the same, but the graph would shift to the left. A minus inside the function parentheses would shift a graph to the right. In this section, we're going to either add a number after a function, and what that's going to do is it's going to move the graph up that many units. And if I subtract a number outside the parentheses, it's going to move the graph down that many units. So the big difference between this video and the first video is the number that's being added or subtracted isn't inside a parentheses. That makes it so I can't duplicate the y's because the y's get changed. It makes it so the graph moves up or down. So these are the really important kind of anchors for this section. And in each of the next problems, 7, 8, 9, 10, 11, and 12, we're going to get a base graph. We're going to move the base graph up, and we're going to move the base graph down. So here's your problem 7. So pause the video and give it a go. I'll move on. I just did 8, so I'm going to do 10. 10 wants me to graph f of x equals x minus 1 quantity squared. I'll do that in black. And I need the number for the middle of my x column. I'm not going to use the table that I used earlier. So the number for the middle of my x column, when I do the graph of x minus 1 quantity squared, I'm just going to go x minus 1 equal to 0. I'm going to add 1 to both sides and get x equal to 1. So when I go to do my initial graph, I'm going to have an x column and an f of x column. And in the middle of my x column, I'm going to put the number 1. And then I'm going to go smaller. Less than 1 is 0 and negative 1. Bigger than 1 is 2 and 3. I'm going to get the y's using my calculator just because it takes so long to do this video anyways. So I'm going to go y equals clear, parentheses, x minus 1 squared, and then second table, next to negative 1 I see 4, next to 0 I see 1, next to 1 I see 0, next to 2 I see 1, and next to 3 I see 4. So I'm going to do my graph. It's going to be a parabola. It's a u as opposed to a v. When you have an absolute value, you get a v. When you have a square, you get a u. So plotting my points the best I can, which really is not that good. So here's the initial graph. It's a nice parabola. Done with part A. For part B, to find f of x minus 5, with the 5 not in the parentheses, the f of x function is x minus 1 quantity squared. F of x minus 5 is going to be x minus 1 quantity squared minus 5. My answer to 10b, f of x minus 5 is going to be x minus 1 squared minus 5. To do part C, I'm going to make my table of values. And when the number in function notation isn't in a parentheses, I'm going to keep the same x values. So my graph is going to have two columns, the x column and the f of x minus 5 column. And in the f of x minus 5, I need to figure that out, but in the x column, I'm going to put -1, 0, 1, 2, and 3. I'm going to enter this on my calculator and get all the y's that I need. So I'm going to go y equals, I already have the x minus 1 squared, so I'm just going to arrow over and enter the -5. So there's f of x minus 1, f of x minus 5. Now I'm going to go second table. Next to -1, I see -1. Next to 0, I see -4. Next to 1, I see -5. Next to 2, I see -4. And next to 3, I see -1. So -1, -1, 0, -4, 1, -5, 2, -4, 3, -1. Not so readable, but I'll try to do better. So -1, -1, 0, -4, 1, -5, 2, -4, and 3, -1. So this graph is going to look something like that. And it's harder to see with parabolas. They don't look like they slide into each other because they keep getting wider in a curved way. It makes it harder to see. But this graph, if you took the black graph and slid it down, it's going to fit right in there and fit exactly. It'll be exactly perfectly fit in without any kind of edge gaps. And this graph, to get from the black graph to the purple, it's 1, 2, 3, 4, 5 units down. To describe the transformation to obtain the graph of the purple graph from the black graph, it's going to be shifted down 5 units. That's because notationally I found f of x minus 5, and that's going to lower the graph by 5 units. That's what this little sheet that I'm going to keep flashing now tells me. All right, so next I need to find f of x plus 3 for part E, and I need to do that in red, so I'm not using up a color. So f of x equals x minus 1 quantity squared, so f of x plus 3 is going to be x minus 1 squared plus 3. My answer to 10E is going to be f of x plus 3 equals x minus 1 squared plus 3. When I go to answer part G, describe the transformation, because it's f of x plus a number, it's going to raise the graph up that number. The transformation, it's going to raise, or yeah, raise is fine, the graph, or shift the graph up 3 units. And I could do that without even sketching the graph. So what the graph of the red function is going to be this function raised up 1, 2, 3 units. It's going to start right there, and I'm going to get another u. When I go to do this graph, I'm going to use the exact same x's. I'm going to use the x's of, so for part F of number 10, I'm going to use those same x's of -1, 0, 1, 2, 3 for my x's, and my y's are f of x plus 3. And now I'm going to get my y's by graphing that on my calculator. So I'm going to go y equals clear parentheses x minus 1 squared plus 3. Now second table, next to -1 I see 7. Next to 0, I see 4. Next to 1, I see 3. Next to 2, I see 4. Next to 3, I see 7. I'm just going to plot those 5 points and make another parabola. So -1, 7 starts off this graph. So -1, 7. So I go left 1, up 7. I'm going to get there. The next point is 0, 4, which is here. then the point 1, 3, which is this shifted up 3 units, then the point 2, 4, and then 3, 7. So 2, 4, 3, 7, and I get this same kind of parabola. And it's higher because when you add a number in function notation, that shifts the graph up. Whereas the purple graph, because I subtracted a number using function notation, it moved the graph down. So we have to get used to shifting graphs up and down and left and right. We shift the graph left and right by adding numbers and subtracting numbers inside the function notation. Adding inside the function notation shifts the graph left. Subtracting inside a function notation shifts the graph right. I can make the y's come out the same, but I have to change the x's. For these graphs, when I'm adding and subtracting a number after the function, I can use the same x's to make my tables. The y's are going to change, and it's going to move my graph up or down. So here's your problem 9. Hopefully you can make a good go at it. Your starting table, you're going to go x minus 3 equal to 0. You're going to get x equal to 3. Your starting table, you're going to put 3 in the middle of your x column and then go smaller, 2 and 1, and bigger, 4 and 5. So you're going to graph f of x, you're going to graph x and f of x for your starting table. And then for each of the other parts that want you to make a table, you're going to use the same x values. All right, so I'm going to do problem 12. It's a graph of a square root, so getting my table is a little bit different. To do the graph of a square root, the algebra gives me the number for the start of my table, not the number for the middle of my table. So I'm going to go x plus 2 equal to 0. I'm going to minus 2 from both sides. And this is going to be the number not for the middle of my table, but for the start of my table. In the other problems, absolute values in squares, the number that I get is the number for the middle of my x column. For square roots, it's the number for the beginning of my x column. For each of the graphs that I do, I'm going to use the same 5 x values. Now I'm going to graph this by getting my y values. So I'm going to go y equals clear second square root x plus 2. Show you the graph anyways. I'm going to get something that looks like that. And then second table, next to negative 3 and negative 4 I have error. The graph doesn't exist there. Next to negative 2 I see 0. Next to negative 1 I see 1. Next to 0 I see 1.4. Next to 1 I see 1.7. And next to 2 I see 2. I'm only rounding these to 1 decimal because I can't graph 2 decimals worth of accuracy. So negative 2, 0, negative 1, 1, 0, 1.4, 1, 1.7, 2, 2. My graph's going to look something like that. Move on to part B. Find f of x minus 5. Well, if f of x is the square root of x plus 2, then f of x minus 5 is just going to be the square root of x plus 2 minus 5. My answer to part B is going to be f of x minus 5 equals the square root of x plus 2 minus 5. And I know that the graph of this is going to be shifted down 5 units because of the way this is written. So I know for part D, the graph is going to be shifted down 5 units. So when I go to do part D, I'm going to say this is going to shift the graph down 5 units, which means this point right here is going to go down 1, 2, 3, 4, 5 units. It actually even means that point right here goes down 1, 2, 3, 4, 5 units. Every point's going to go down 5 units. Let me get the y's by making my table. I'm going to make my x column, which is negative 2, negative 1, 0, 1, 2. And then my f of x minus 5 column, which is going to be all these numbers subtracted 5. So now I'm going to go and graph that. So I'm going to go y equals square root of x plus 2 minus 5, and then second table, error, error, next to negative 2 I see negative 5, next to negative 1 I see negative 4, next to 0 I see negative 3.6, next to 1 that rounds to negative 3.3, and next to 2 I rounds to exactly negative 3. So negative 2, negative 5, negative 1, negative 4, 0, negative 3.6, 1, negative 3.3, 2, negative 3. Plot those. Here's the point 2, negative 5. The next point, negative 1, negative 4. Then the point 0, negative 3.6, 1, negative 3.3, and 2, negative 3. And graph this square root. And again, if I did this on my calculator, you'd see basically the graph that I just came up with there, at least close enough to that. And this is exactly that graph shifted down 5 units. The rest of number 12 wants me to first find f of x plus 2. Since f of x is the square root of x plus 2, f of x plus 2 is going to be the square root of x plus 2 plus 2. My answer to part E is f of x plus 2 is the square root of x plus 2 plus 2. Because that number is added and it's not inside the parentheses, it's going to move the graph up 2 units. So when I go to do part G, it's going to shift the graph up 2 units, which means this black graph, each point's going to go up 2. This point that's right here is going to go up 2. This point that's right there is going to go up 2. And I'm going to get exactly the same graph. It's going to look something like that. Without even plotting any points, I can predict what it's going to look like. But I'm going to plot points to make it more accurate. For each of these kinds of graphs, I steal the same x's. So my starting graph for this, when I make my x and f of x plus 2, I'm going to use the same negative 2, negative 1, 0, 1, 2. I'm going to enter this on my calculator. Y equals clear second square root x plus 2, close the parentheses, plus 2. Second table, you get negative 2, positive 2, negative 1, positive 3, 0, 3.4, 1, 3.7, 2, 4. Now I'm going to plot those points. The first point is negative 2, 2. Second point, negative 1, 3. And then 0, 3.4, 1, 3.7. I kind of plotted those points reasonably well already. That's a reasonable graph. It's the black graph shifted up 2 units. Done with that problem. It's number 12. I think this is where I'm going to pause and make a part 3. I'll flash your number 11 up on the screen right now to give that a go. And then we'll move on to a part 3. There are probably going to be like 5 parts to this video. I'll put each concept in its own video. So give number 11 a go, and we'll have the first 12 problems done. Unfortunately, there's like 50 problems in this section.